I'm going to show you two different ways to come up with the slope of the line that passes through these 2 points. The first method is going to be using the slope formula. So I'm going to put here y1 minus y2 over x1 minus x2. And you might be familiar with it might be familiar to you to see it as y2 minus y1. So don't forget, if you put y2 minus y1, x2 minus x1, it's the same. You get the same answer either way. And if you want to see the actual examples like that, the comparison of those two formulas, make sure you watch the video included in this section of the worksheet. And what I highly recommend you need to do is to label your points, because if you don't label it, that's when you start to make mistakes. So I'm going to label this to be my first point, and I'm going to this one to be my second point. That's all these subscripts, these numbers mean. Point number 1, point number 2, that's it. And then that's going to allow us to substitute it correctly into this formula. So I'm going to put m equals, I put down my minus signs because we have to subtract. And I usually exaggerate them a little bit more than what's in the regular formula. And the reason why is because when you substitute negative numbers, you might make mistakes and think that this replaces a negative in the numbers. But even though these are all positive, I'm not going to have to worry about it. But that's usually why I exaggerate these. So I know the numbers that I'm replacing are, the correct numbers. But here in the formula, I have to do the first y value, which is this one, 1. The second y value is 1/2. And then the first x value, which is this one, 3/2. And then my second x value is 9/4. And now we just got to subtract. So 1 minus 1/2 is going to give me 1/2. And then I got to do 3/2 minus 9/4. So if I want to do that work on the side, 3/2 minus 9/4, I got to multiply both of these by 2 to get a common denominator. So I get 6/4 minus 9/4, which is negative 3/4. So that'll be the denominator, negative 3/4. And just, by the way, for the 1 minus 1/2 is the same idea, just in case you needed that. 1 is the same thing as 1/1, right? 1 divided by 1 is still 1. And a common denominator here, I'd have to multiply both of these by 2 to get 2/2 minus 1/2, which gives me 1/2, which is what I had before. And now, in order to do this problem here, we have to actually divide. So 1/2 divided by, so when I read this, this is 1/2 divided by negative 3/4. And now to divide this out, I'm just going to compute, follow through with the algorithm for division. And that means we're going to do 1/2 times negative 4/3, which gives me, I can simplify the 2 and the negative 4 here. If I divide this by 2, I get 1. Divide this by 2, I get negative 2. Right, that's the greatest common factor for those two. And now I get 1 times negative 2 is negative 2 over 1 times 3, which is 3. And I can see my slope is negative 2/3. And then the second method, which is probably not ideal when you're dealing with this type of fractions, but I use this method, changing y over changing x. And all this is just a fancy symbols and terms for how far apart are the y values, how much did it change by, and how much did the x values change by. So if I look at the y values, I know that from 1 to 1/2, that's only half a space apart. That's how far apart those two numbers. So the y would be 1/2. That's how far apart those two y values are. And then to figure out how far apart these two values for the x's are, is pretty much what you did. So, sometimes it's easier with whole numbers or integers. But with fractions, if you want to figure out how far apart they are, you got to find their difference. In other words, you got to subtract it, which in this case, when you subtract them, we already know that we're going to get negative 3/4. So that's how far apart those two numbers are. So notice that's pretty much all the formula is doing. When you subtract the two numbers, you're just figuring out the distance between those two numbers. You're figuring out how far is it from 1 to 1/2. And then you can see here, it's a 1/2 space away. And the same idea applies to the denominator. But now to do this, I'm not going to do it out because this is just the same exact thing we just did over here. And when you divide it out, you're going to get negative 2/3 for your final answer. Well, actually, I just realized too, let me add that if you are this is saying how far apart, how much did it change by. So the x values, if you did figure it out, you would do like the distance, which is the absolute value. So it'll actually be like, that's how far apart their numbers are. It's just 3/4 of a space apart. That's how far it's apart from 3/2 to 9/4. So I wouldn't actually put a negative. I'll just put the absolute value because, again, we're talking about the distance apart from the two numbers. And now, when you're doing this method, so again, if you were to actually now divide this out, I know that my final answer would just be what I had over here. It would be 2/3. It wouldn't be negative because I didn't calculate which one is negative and positive yet. So to figure out if your answer should be a positive or negative, this is what you have to do. you do a quick sketch of your 2 points. So if I were to plot the first point, 3 halves 1. 3 halves 1 is about 1.5 and 1. So 3 halves 1 is 1.5 and up 1. So that'd be that point. And then my next point, 9/4 and 1/2. 9/4 is about 2 and 1/4, which is about somewhere right here. And I got to go up 1/2, which is right here. So again, this is just a quick sketch. And you can see that if I were to draw the line through these 2 points, it's actually a negative slope, which means my answer should be a negative number, because your slope in the picture, right, when you draw your slope of the line, it's always going to match the type of answer you get. So negative slope, negative number for your answer. And that's the second way you can do this problem.